Hi guys, today we're going to solve a very classical interview question, which is reverse a linked list. It is a very classical problem. It asked in every interview, and recently also there is a controversy going that nowadays the college graduate don't know how to reverse a linked list. It was a funny conversation going on recently. So today we'll see the problem and we'll solve this problem using a stack, a naive solution, and then we'll solve using the iteration space optimized one, and then we'll talk about the recursion solution also. So without wasting much time, let's get into the problem. And one more disclaimer is like the first two solution is more than enough. Recursion is the additional one, which is kind of a bit confusing, but I will try to explain as simple as possible. So what the question asks you to do is they will give a linked list. So this is going to be a linked list, and your task is to just reverse it. So reverse in the sense you need to find somehow to reverse this chaining. So 3 need to be chained to 2, 2 need to point to 1, and 1 need to point to 0. This is the reversed order of a linked list. Similarly, how you reverse a list, you have to reverse the given linked list. So what is a naive approach? So what is the first solution coming to mind is you can just pop out the entire thing and you can store it in a list. You can reverse the list and you can rebuild the entire list. Yeah, that is a pretty good solution. That will work. But the point of a question is you need to find somehow to reverse this chaining process. And this is a utility based question, which means there is no algorithm involved. The interviewer will check you how your thinking works, how you work with the problem. This is not a utility based solution. So what you're doing is you're taking a stack, you're just storing it, and you're just popping out and reapplying it. But that's not the point of the question. The point of a question is you need to find way to manipulate this chaining to reverse itself. Then you can get the reversed linked list. So now let's talk about the naive solution in detail. And okay, now what we'll do is in the naive solution, we'll try to iterate the entire list. We'll pick it and store it somewhere else. For storing purpose, we are going to use stack. You know the stack property is last come first serve, last in first out. This is the property of stack, right? Why do I use stack is, I mean, if you're using normal list, what you will do is we'll just basically put entire thing into a list and you just reverse them. So there's no point of reversing it when you can use a stack. So basically stack property is last come first serve. So what you can do is just take everything and put it into a stack, and then while accessing the stack you will get the last element, right? So you can simply take the last element and replace with the first one. That's why I use stack in this case. So now let's do this dry run. So first iterate every single element in a list, linked list. So let's go this, take this and put it into a stack. And again, go here and take the number 2 and put it into a stack and follow this process. We'll put a 3 and we'll put a 4. Now what you will do is, what is the property of stack? So you will access the last element. And now what you can do is pick the last element and just replace with this current head. It will look like this. Now again do the same process. Pick this and replace. Pick this, replace. Pick this, replace it. Now one will point to the null, and somehow we reverse the entire linked list using the stack based approach. Now let's write this code for this, guys. We'll write this quickly and then we'll move to the appropriate solution for this problem. So initially we'll have the stack. So stack, will declare a stack, and then we need to have the temporary pointer which point to the current head, right? So let's declare that. So temp is going to be head. And if we think about the solution, what we did is we just iterate to this entire list and store the value into the stack, right? So now let's do this process. So while temp is not equal to head, temp is not equal to null. So what this indicates is we need to loop until we come to this particular position. We need to loop until this. That's what this while loop condition tells. So for each and every step, we just pick a value, current value, push it in the stack. For that, st dot push temp dot value. And then what we need to do is after pushing, we need to move the pointer, right? So temp is going to be temp dot next. Now this will move the current pointer to the next particular point. And then this will keep on moving until unless we reach the end. So what we did after reaching the end is we just start to pop the element from the stack and replace with the current pointer. That's what we did, right? So now let's do this process. Again, we'll have the temporary pointer. So temp is going to be, again, will point to the head. If you remember carefully, it will again point to the head. We just pop the element and replace this value to this top of the value. That's what we did. It's very simple and naive approach. Compared, there are few other solutions there. What we'll do is we just iterate the same. We just iterate it, put it into a list. We just reverse a list and again we'll rebuild the entire linked list. That is kind of complicated way. This is the much optimal compared to those solution. Just simply replace the value with the top of a stack. That's very simple. So we'll write the code for this. So again, we need to loop until the end position. So temp is not equal to null. And then what we'll do is the temp dot value is going to point to the top of a stack. So how to get top of a stack is very simple. st dot pop. Pop will give you the top of a stack. And then next what you'll do is just move the pointer. So temp is going to be temp dot next. I think it's very simple code, I guess. And if I talk about the time complexity, obviously this is going to take big O of n time to access this. Big O of n time again to replace this, it will take big O of n time. The overall time complexity will be big O of 2n. And space is going to be, obviously it's going to be n because we are using a stack. Space is big O of n. Now let's move to optimal solution, guys. So what the optimal solution is, like we need to optimize the space, which means we cannot use any kind of data structure. So at the time, what we have to do is we have to basically play with this kind of connections. We need to play with them and somehow find a logic to reverse this entire linked list. So if you take all the linked list problem, the most of the problem will be on this particular pattern only. Like you need to play with these links and you need to solve this problem. That's how you have to solve the linked list problems. You cannot kind of use external data structure to do the stuff. That's completely wrong. We have to find or we have to play with this pointer and somehow reverse them. So what do I mean by it? So everything will be stays in the same place, right? It will be stays in the same place. You just need to reverse this pointer. Just reverse this, and 4 will be pointing to 3, 3 will be pointing to 2, 2 will be pointing to 1, and 1 will be pointing to null. And now 8 will become our new head. Am I right? 8 will become our new head. We need to find a logic such that you have to reverse this pointer backwards. You need to find a logic for that only. So now let's see in detail how we can do that. Now let's see how to reverse a one particular node alone, guys, and then we'll take one more extra node and we'll see step by step. So now what we are doing is, it's very simple. Now what we have to do is, let's say we take a one data, it's going to be one node and it has something to the front, and let's name this as next node. Okay, this can be next node. This is going to be a temporary node. Let's point to this temporary, and we need to reverse a connection, right? We'll have something as a previous node as well. So what we need to do is we need to just reverse this point. Instead of pointing to this side, we need to point to this back side. Like how do we do that? It's very simple. So what I'm telling is this temporary next should point to the previous. Am I right? This is what we have to do it. We just need to change this pointer to this particular side. And next step, what we have to do is after pointing this, we need to move to the next pointer, right? But if we do this, we lose track of this next position. Am I right? So once we cut off this particular point, we just lose the connection to move to the next node. For that, what we can do is we can have a next node which will point to this particular entire node. For that, before moving this, just store this in a next variable. So next is going to be temporary.next. Now we just preserve this particular node, right? Now we just preserve this in a next variable. So once we did this, what we have to do? Tell me, guys, what we have to do? Once we connect this particular node, we have to update the previous, right? For this particular node, this is the previous. But for this, which is the previous node? Tell me, guys, which is the previous node? for this particular node, this will become as a previous. Am I right? So now let's update the previous. So previous is going to be temporary. I hope you understand this. Now we need to update the previous to this particular node, right? Now we made a connection from this node. We made a connection to the previous node, and we need to update the previous node as well, right? Because this must be attached with the previous node. For this particular node, previous is going to be this node. Instead, for that we have to move the previous as well. So previous is going to be temporary, and then what do we have to do next step? Tell me guys. We need to move the pointer. Again, we just put temp is going to be next node. Now we'll take this particular node. We'll take this particular node and we'll follow the same approach. For that, let me draw out quickly. Let's keep this aside, and now this will become as a previous. Am I right? This will become as a previous, and this will become as a data. Next, I mean, once we move this will become as a data, and this will have some particular next node. Am I right? This will have some next node as well. Now, what do you have to do? The same process. We need to break this connection. You need to reverse them. That's what we wrote this. And after breaking this, we'll just lose track of the next pointer. For that, we're just storing this in a variable, and then now we're just switching the connection. For that, we simply take the connection and map it to this. Temp.next will be previous. Very simple, right? And then again, we have to make this one as a previous. For that, previous is going to be temporary, and then now we just move to the next pointer. I mean, now we'll just move to this particular place, and we just keep on doing this. I hope you understand this approach. Now let's take an example from this and we'll see. Okay, now let's take this example and we'll see how this particular logic works. Now the current pointer will be starting off this node, right? As I discussed, this is going to be a temporary node, and these are going to be a next node. So what I said is, you need to preserve this, right? As a first step, we need to preserve this particular nodes for a next movement. So let's do that. Now this will become a next node, right? And now what we have to do? We just need to cut this point and make it as a previous one. So let's do that. Now it will look like this. So previous is going to be null, and if you point temporary dot next, this will look like this. Am I right? This will look like this. Now what you have to do is, what we did is, we just make this as previous node. I mean, this particular node as a previous, because for this 4, which is previous one, for this 4, 3 is going to be previous. That's why we just make this as a previous. This is going to be a next previous node. And we just move the pointer. You can see now we just move the pointer to the next one. Now this will look like this because we just move the pointer, right? And this will be our next pointer. Am I right? This is going to be our next pointer, and this is going to be a current pointer, which is a temporary variable. Now we need to just remove this pointer and connect to the previous value, right? What is the previous? 3. So cut this pointer and make temporary dot next is going to be previous. Very simple. Temporary dot next will be a previous. Now it will look like this. Am I right? Now it will look like this. And once we did this, we update our previous value. Now next previous is going to be this. Am I right? Because for 8, which is going to be previous 4. So once we update this, we just move the pointer, right? We just move the pointer, next step, and we just erase this point. And now there's no more extra nodes, so there's no next pointer. So simply what we have to do is, we have to just attach temp.next previous, and if we do that, it will look like this. And it's very simple, and just move the pointer, and we can simply return this is going to be reverse order of this particular input. 3, 4, 8. If you reverse this, it will look exactly like this. And I hope you guys understand this. Let me write a pseudocode. Actually, I don't need to write as well, because we already written over here. And simply what we can do is, we can just copy this and write some extra lines. Let's say temporary is going to be head, which is pointing to the head of the node, and then we'll have previous. Previous is going to be null. Initially previous is going to be null. So remember carefully, initially previous is null. And we have to iterate until we reach the end of the node. So let's write the for sorry, while loop, while temp is not equal to null, till that we have to iterate it. Now we can simply paste this entire code which we written over here, which is temp, which is next. We need to preserve, right? We need to preserve next upcoming nodes. So next is going to be temp dot next. If you remember carefully, we just need to reverse the point from this to previous node. So temp dot next will be previous. Am I right? Next dot temp is going to be previous, and then we need to update the previous as well, right? So previous is going to be temporary, and then we have to move the next pointer as well. So temper is going to be next. It's only 9 lines of code and it's very simple one. And if I talk about the time complexity of this particular problem is going to be big O of n. This takes big O of n. If I talk about space, it's going to be constant space because we are not using any kind of external data structure. We were just having the pointers alone. We are not creating any extra additional spaces. So the space is going to be big O of 1. I hope you understand this particular problem very much and I explain as easy as possible. And there is one more solution also for this, which is using recursion. So why do you use recursion? And let's see the basic of recursion as well. So what the recursion will do is it will just break a bigger problem. Right now, our bigger problem is to reverse this entire linked list, right? And what the recursion does is it will just break the entire problem to a sub problem. And this again, this sub problem will break into the another sub problem and again another sub problem, and it will reach a certain base case, right? It will reach to one particular base case. So this is the mechanism or idea of the recursion. You just break the big problem into sub problem, and that sub will break into sub, and again at last we'll have one base condition. Am I right? This is the working principle. Now let's see what the each sub problem will do. We'll write the sub problem is going to be, what sub problem will tell is give me the reversed linked list except myself. Let me repeat again. What the each sub problem asks you to do is, here is my next node, just get back to me the reversed list not including me. Let me explain with this particular thing. Let's say this is a bigger problem and this sub problem telling is I will give you my next node. What is the next node? This is the entire thing. I will give you my next node, just give me the reversed version of it, not including me, which means this particular thing is asking the reversed version of this entire thing, which will look like 2, 3, let's draw this out quickly, 5, 8, and the reversed version will look like this. Am I right? Just give me the reversed version of it. I will do my stuff. That's what the sub problem asks you to do, or that's the definition of a sub problem. What the base condition tells is I am the last node. I will return myself as a new word. The base condition is when you reaching the end. If you reach at the end, what the base telling is I'm the last node, guys. I'm the last node. I will return myself as an head. If I write if condition, it will look like this: if head is equal to null, or head dot next is equal to null. If this happens, which tells that we reach the end of the node, and if I'm the end node, I'm going to be the new word. I'm going to return myself. If we see this, I mean, this will become as a new word, right? Once we reverse this, this will be our new word. That's what the base case is telling. I will be a new word for you guys. So follow up me. So we can simply return head. This is what the base condition tells. And again, sub problem tells that I'm giving my next node, just get back to the reverse version of it. I hope you understand what is the base case and sub problem of this. Now let's see with an example how to solve this. Now let's see the concept in detail, guys. For simplicity, let me take this as our problem right now. Right now we have two nodes, 4 and 8, and 8 is pointing to the null. Now let's try to solve this sub problem. And this is the entire problem. Now this is going to be a sub problem. If I solve for this particular one, this will return itself as an 8 because this is a base case. Remember, the base case is going to be at the last node. Whenever I'm reaching the last node, I will tell myself as a new head, right? This the sub problem will return like this. 8 is going to be there and 8 will point to null. Okay, 8 will point to null. And this is going to be the current head, right? This is going to be the head and this is going to be friend node. What you have to do is very simple. we have to connect friend dot next to head, which will look like this. Friend dot next, please consider here carefully. Friend dot next will map to this, and the head dot next will map to null. For that, head dot next is going to be null. Very simple. Now we have to return the head. We have to return the head. What is the current head is? This is the current head. So just return friend as an answer. Very simple. And if you don't understand, let me add one more node and explain to you guys. Okay, I added one more node extra here. Now what we did in previous step, so this is the head, I mean this is the entire problem, and this is going to be the sub problem, right? What the sub problem did, so the sub problem will return this particular node, am I right? 4 8 null. Sub problem will return this particular node, and then what we have to do is the same approach. So friend dot next will map to the head, and head will map to the null. So again, if I do that, it will look like this. 3 and 3 next will be null. I hope you guys understand. It's very simple. Now let me take 4 node and explain to you guys. Now this is going to be friend. And if we try to solve for this particular sub problem, this node will return this particular result, right? This is the reversed version of it. Now attached to yourself. The simple same approach. Now this is the friend, but now this is going to be the friend. The friend dot next will be 2, and head dot next will be null. Simple, very easy. I hope you guys understand this. I mean, it's okay, fine if you don't understand this particular thing, because it's very difficult to understand at the first time itself. So it will take some time. For anybody, it will take at least 3 to 4 times of doing this by yourself, because it's very difficult to understand this particular type of problem. So don't worry guys, if you don't understand, it will take some time. For some people, they might understand at the first time itself. And yeah, fine, let me tell this thing one more time. So what we have, sub problem and the base case. Base case is like when we reach the last node. When we reach this, it will tell itself as I'm the head of it. So keep myself ahead and do remaining stuff. And if I talk about the sub problem, or the sub problem is telling that I will give my next node, just give me the reverse of it. I will attach to myself. That's what the sub problem did. So if you take this is the sub problem, so this sub problem will return you this particular result. And this is the current head holding it, right? This is the entire problem. Now this is the sub problem. Now sub problem has written this particular value. Now what we did is we just point the friend dot next to this head, and we just cut the link from the head and point it to the null. That's what I did. Head dot next will point to this null. And now this entire thing is going to be the solution for this sub problem. I mean, this entire node sub problem result is going to be this. And again, we do the same approach for this particular node. We'll attach 2 to the 1 and 1 to the null. And if you see now the entire list is reversed completely, which is the expected answer. We already written the pseudocode because this is a step we are just going to follow, but that's fine. Let me write one more again, and we'll just code this up. So function as an input, we are just going to have a head, and don't forget to write the base case at the beginning. I think we already seen what is the base case. So if head is equal to null, or head dot next is equal to null. If this happens, we simply return the node itself, return head. This take care of the base case, guys. Now next step, what we have to do? Next step, we need to do the recursion call, right? So for that, let's have reversed list. Reversed list is going to be function of what is the problem tells. I will give my the next node, not the word next node. So what you have to do is we have to pass head dot next over here. I just pass you my next node, give me the reverse version of it. Very simple. Now what you have to do next step? The same thing. Now let's store the friend node. Friend is going to be head dot next. Why do I take head dot next? Why I'm not taking this is, let me show you guys. If I take this particular problem, what the subproblem returns? This one, right? subproblem written this particular thing, which will point to null. So I cannot use this as a friend node. Am I right? I cannot use this as a friend node. If I take this particular problem, what is the friend of it? 3. So I can simply use head.next as a friend, and I can join the particular node. It's very simple. And again, for people who are seeing for the first time or first time, it might be a bit confusing. So just practice little and you can simply understand this particular problem. And if I remember carefully, I will make friend.next is going to be head, and head.next is going to be null. And then I simply return the head, right? I simply return the current head. So return head, return friend, sorry. I simply return the current friend. So return friend and just to close the loop. And this is the entire code, guys. And if I talk about the time complexity, time is going to be big O of n and space is going to be big O of n, because recursion use call stack which will keep track of all the recursion stack, which is an easy problem. Even though we have talked a lot more different solution, this is an easy problem because it's the basic interview question. If I want to take clearly, it's going to be the phone call round, the technique of phone call round, telephone round. So before moving to the interview, they will just check whether you are a right person to sit in the interview. For those kind of things, they used to ask this kind of question. So let me write the solution for this, the iteration one. I think I can write the recursion also. First, let's write the iteration solution, guys. So what the iteration tells. So initially, we are going to have the previous node, which will point to the null. In Python, we used to do none. And then we have the temporary node, which will keep track of the head. And if you remember carefully, we need to preserve the next nodes. So next is going to be temp.next. And then what we did, we just simply point the current temporary to the previous one, right? Current to the previous one. So temp.next is going to be prev, and previous is going to be the temporary. We have to make the current one as a previous. Previous is going to be temp. And the next step, what we did, we just move the pointer, next pointer. So again, temp is going to be next. And simple. At last, we can simply return the previous. Yeah, it passed the test cases, but let's submit this, see whether it passing fully or not. Fingers crossed. Yeah, it passed all the test cases. Now let's write the recursion code for this, guys. Recursion code is going to be much simpler. We'll have the base case if head is equal to null, or head.next is null. Head.next is none. If this happens, just simply return the head over here. If not, do the subproblem. What the subproblem tells, I will give the next node, just give me the reverse of it. Same, again, write the same function here, self dot function. I'll just give my next node, just give me the reverse version of it. And if I remember carefully, what we do is we need to have the friend. Friend is going to be head.next, and friend.next will map to the head. Friend.next, it's going to be the head, and head.next will be the none, or you can tell null. Very simple. If I remember carefully, we need to return the head, current head, current friend. And if I sum this code, let's see whether it's passing or not. It's getting failed. What we missed over here. Yeah, guys, I'm sorry. We need to return the reversed version of this one. So reverse need to be returned. So let's submit this and see. Yeah, this recursion also passed all the test cases. I hope you guys enjoyed this video, and I'm sorry if I take a lot of your time, but this is the basic interview class question. So please pay attention to this particular problem and work out by yourself and try to understand the recursion. I think iteration solution you would have understand, it's very much simple, but recursion might take little time compared to the remaining solution. So just put some of your time and read by yourself, work out by yourself, and understand it. So we'll meet again in one more video. Until then, bye.